Good morning or good afternoon. I am Dr. Saad Irtza. Firstly, I'd like to sincerely thank to the organizers and especially to Dr. Farooq for giving me this opportunity to present today. It is a pleasure to be speaking about one of the most exciting areas in artificial intelligence, which is AI agents and intelligence autonomous systems. When we say about AI agents, we are referring to the system that can perceive their environment, make decisions, and act accordingly to achieve the specific goals. They combine machine learning, reasoning, and automation to perform tasks that once required human intelligence. Think of them as digital entities that can. So, main areas that I will be covering today are what are the AI agents? What is the difference between the non-agentic and agentic framework? And how can we design the AI agents to act more maturely? So, AI, as we all know, is a very broad area. When we talk about compound AI systems that consist of AI and the machine learning, some statistical tool as well. Within the compound AI system, we have the agentic AI. Agentic AI is an AI system that have AI agents in it. So what are the AI agents? AI agent is a core component that require a brain, a memory, and planning tool. So we're going to talk about AI agents, which is a core component of agentic AI systems. Agentic AI is a part of the compound AI systems, and compound AI systems fall under the umbrella of the AI. So what is the AI agent? So as I said before, AI agent is an intelligent application that uses an AI model and other tools to iteratively plan, execute sequence of actions to complete a complex task. So instead of going through the theories, equations, and those kind of stuff, you are you are dealing with them every day in every class or every lectures. So let's take an example from the real world. Let's automate the customer service operations using the agentic framework and the non-agentic framework. So let's take a pause and think about you're being asked to automate a customer service operations. How, what's the first thing that will come into your mind? Definitely the workflow, the how the system works. So the first question will be, if you don't know about the customer service system, then the first question will be, what is the customer service operations? What are the operations inside? What are the steps involved in it, right? So from left to right, if we go through this diagram, the very first thing, the middle one here, who is wearing a microphone, this is an agent. This is a human agent. And the task of this agent is to receive the call, to receive a query from a user, and retrieve the information from the backend system, look into the rules and the regulations, and respond back to the same user. So for example, if the user asks, can you help me return my last order? Then what this human agent will do? This agent will first think about what is the order, when the order was purchased. This is all about the reasoning module here, reason about what to do. Then what he knows about what was the order and when he purchased it, and what are the guidelines of the order, or what are the order details or order history or um, order brochures or something, product brochures or something like that. So that's the information he or she will look at. Then he will look into what the customer wants, why he wants to return the order. Does he want, is there anything wrong with it? or it's just a change of mind? And what is the return policy? It might be possible. It might be possible that with some products there is no return policy. You can't return them, but in some you can return it maybe in 30 days or maybe in 60 days, right? So this is all the processing. This is all the information that this agent is accumulating and taking action accordingly and responding back to the user, right? Now, this is, we were asked to automate this, and we have gone through the steps that are involved if we want to automate it. Now we have two options. So first option is using the non-agentic workflow, which is hard-coded set of hard-coded actions. So from the user prompt, we have action 1, we have action 2, and then we have the final output. Doesn't matter what the user prompted. Maybe I'm asking about something else, which the company doesn't sell at all, but it will go to the action 1 and action 2, and it will lead to the final output, which is the best match, right? But in the agentic workflow, we have the brain, we have the LLMs, we have the agents. They will have the capability to think about it. What is the product? Either do we have the product in our catalog or not. So it will act accordingly. And it doesn't matter that which action to be performed first. Maybe in some of the scenarios, action 2 will be performed first and action 10th action will be performed at the last. So it totally depends on the user prompt. What is the user prompt? Either we need to return the document, or sorry, either we need to return the product, or we need to fix the issue by sending some product components instead of the entire product. So that's the agentic workflow. Now let's design the agent on the customer solution. So the agent receives a message saying that, can you help me return my last order? And the first scenario is, if we are provided with the order ID or the email, then the very first thing the agent will reason about, I should look up the recent orders and our return policy. What was the order? Is there any return policy on the policy document? And what the user is asking me, either why he want to return the order. Is it just his change of mind, or is the product faulty? And then it will query the policy document that, is there a return policy exist? If yes, then it will be communicated with the user. But if the product is faulty or customer is having an issue while connecting, let's say the product is a headphone and he's having some issues with connecting the headphone with the laptop, then he might suggest, okay, try this option, try that option, right? So then maybe user will change his mind to return the order. And it might also be possible that there's no order ID is provided. So then we don't need to go through all of this process, all of this return policy, fetching the information, blah, blah, blah. So it all depends on what the user query is. And this reasoning module will decide its next action accordingly. And once the all the process or all the threads are being performed, then it will be communicated back with the user. So that's how the AI agent will work on this scenario. So how the agent achieves this? Main component is the tools and the LLM. LLM is the brain of the of the agent, and the tools are the software services or software APIs that are accessible to the LLMs, that it can call when needed. So for example, fetching data from the table, sending the email, or sending a document from a particular location in the hardware, the hard disk, is any is one of some examples of the task. Some examples. So how to decide that this task can be performed by a tool is anything that we can perform in programming language, any programming language, C, Java, Python, C Sharp, C++. If we can write a software, if we can write an API, then definitely that can act as a tool. So tool is the essential component of the LLM, and LLM is an essential tool of the agent. And we repeat this process until the agent decides to respond back to the user. So we have learned now the core components of the AI agent, which is LLM, also known as the brain, tools that can perform the specific task, and a memory. Why we need a memory? Because it needs to remember what's being asked in the previous prompt. So for example, if I start the prompt by asking about the headphone and I need further information, then I may ask a second question. It's kind of a chatbot, a conversational chatbot, right? So if I ask a follow-up question and the agent has to remember that what's being asked before. I don't need to provide the order ID or the information that I've asked earlier. So LLM, tools, and memory. These are the three core components of the AI agents. So let's discuss some best practices of designing the agents. And designing the agent means designing the tool, which is one part. We need to write the APIs, we need to write the software. We can use the existing ones if available. But if not, then we need to write it definitely. But what about the LLM? How we train the LLM? LLMs are already trained. OpenAI or the Google, they have Gemini models, some Chinese models, Claude, Sonnet. A lot of LLMs are available these days. So first, how to decide which LLM to be used. Obviously, one depend on the budget, depend on the cost involved. Each LLM has associated with particular tokens, and we have to pay on the usage of the tokens, right? So that's one scenario. So let's say we decided that we are going to use the Gemini one. It's a cheaper one, or it serves my purpose. That's fine. I don't need a hi-fi LLM now. Now we have the LLM. Now how to design the LLM? How to fine-tune the LLM? One way we can do it the quicker way by using the prompts. We can give the instructions to the LLM, and how to give the instructions. That approach is called REACT. REACT stands for reason plus act, which means reflect on the problem given and the previous actions taken. Choose the correct tool and the input format to use. Do not jump to the conclusions. Define the strategy, like this is step 1, step 2, step 3, and then follow those steps to give me the final answer. Okay, so I will give you example here. There are basically three columns on this screenshot that I've also highlighted. So the question that I'm asking from the LLM is how many R's are in the word strawberry. So the LLM, what it tells me, it's saying there are two R's in the word strawberry, which is wrong, right? There are three R's. But what happened is it saw the word, it saw the question, and it jumped directly to the solution to get me the final answer. And there is no thinking involved, there is no reasoning involved, but In the second one, I modified the prompt. So you can see add system prompt. So I have added the system prompt, which is also I have highlighted in the second column, and I said that think about it step by step. So that's a reasoning component that I have added into the LLM. Now, what is the output? Output is to solve this. Let's break down the word strawberry into the individual letters and count the number of times the letter R appears. Then the word strawberry is spelled as all the letters, and then it's counting the letters, and then it's giving me the answer that there are 3 R's in the strawberry. So this is the reasoning, and then acting is on each steps that he has decided, and then formulating the final response. So this is the best practice that when we design the LLM, or when we ask the LLM to search for a particular information, then just don't ask the question, rather explain that, think about it step by step, or any thought process that you want the LLM to perform, we should be adding into the system prompt as well. So after giving the prompt that you should be doing this, think about it step by step, and now the second level of information that we should be adding into our prompt is if there's a, you know, you're asking about a customer product, then it's better to give them the instruction in a phase that, okay, this is the question. First reason it out, then plan it, and then take action. Instead of just reasoning it out and giving me the answer, or just going through and performing the step, let's plan it out. So in the first column again, in the first row here, I'm just saying let's think the step by step. So it's thinking it, and then it's giving the rest of the class. So I basically asked a question, so it is reasoning it out, but it fails to plan it accordingly. But when I ask it, let's first understand the problem and develop a plan to solve the problem, then let's carry out the plan and solve the problem step by step. So it's basically you're asking a child that this is the problem and this is how you should solve it. But we're not telling it how to solve it, we're telling it you should be thinking about how to solve it. So instead of just solving the problem, first understand the problem, or understand the question, um, reason it out, plan it, and then solutionize it. So you can, I'm running, I think I don't have enough time to read the question and how it answers in the first attempt in the second one, but I hope you will get the slide. So look at the question, how the LLM answers it. So you will see the clear difference here. Right, so once we design all these prompts, we will design all the systems, tools, and assign the memory, then how we develop the life cycle, the agent development, or the model life cycle. These are the main steps involved in it. One is the prepare data, building the agents, then evaluating the agent, which is very important because whatever agent is doing, we don't know whether it is right or wrong. We can't simply design the agent and deploy it in production and saying that now you should be handling all the queries from the customers. Now it might be possible that we end up with returning all the orders that we have sold in the last month, right? So this is the evaluation part, where actually we give some use cases, we give some dummy data or the past year's data to the agent and think that, okay, this is the customer orders. These are the queries, and let's see how you solve it. And if it gives us a good accuracy, then definitely we deploy it in the production. And then when we deploy it in the production, we again keep monitoring the uh, output of the agent and define some guardrails to further improve it. So to conclude, we have looked at how AI agent works, and I hope this presentation gives you a clear sense of how intelligence and design come together to create systems that learn, adopt, and assist us effectively. Once again, I would like to thank the organizers and Dr. Farooq for the opportunity to share this work. It's been a pleasure speaking with you today. Thank you.